this first part of data analysis for solving technical problems. In this part, we will cover the initial three phases of analyzing data by using the CRISP-DM standard, a framework that provides a structured approach to handling complex datasets, ensuring that the process of data analysis is both efficient and effective. The remaining three phases will be covered later in the second part of data analysis for solving technical problems. Now, let's begin by defining what the acronym CRISP-DM stands for and quickly browse through its phases. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. We shall use data mining and data analysis as synonyms throughout this presentation. CRISP-DM's popularity stems from its flexible yet comprehensive approach, which encompasses 6 key phases: business understanding, data preparation, modeling, evaluation, and deployment. This initial phase focuses on understanding the objectives and requirements of the project from a business perspective. In this phase, the data analysts begin the initial data collection and familiarizes themselves with the data. Data is rarely clean. This phase is dedicated to cleaning and transforming raw data into a suitable format to make it ready for subsequent phases of data analysis. The remaining three phases of CRISP-DM will be discussed later in Data Analysis Part 2, the next module. Let's now talk about visualization. Visualization plays a crucial role in data analysis, acting as a bridge between complex datasets and human understanding. It often serves as an essential tool for interpreting and communicating findings effectively. It transforms abstract numbers and data into visual formats like graphs, charts, and maps, making it easier to identify patterns, trends, and anomalies that might otherwise go unnoticed in raw data. Data mining, with its ability to discover hidden patterns and insights from large datasets, finds applications across a wide array of fields. So, what are typical applications of data mining nowadays? Let's quickly scan through some of them. Used in retail, this application helps in understanding the purchasing patterns of customers by identifying associations between different items that customers buy together. Businesses use data mining to segment their customers into distinct groups based on similarities in behavior or preferences, enabling more targeted marketing strategies. Financial institutions employ data mining to identify unusual patterns in transactions, which could indicate fraudulent activity. Medical practitioners and researchers use data mining to analyze patient data for trends and patterns that can lead to better diagnostic techniques, treatment plans, and understanding of certain diseases. Data mining is used to analyze historical stock data, financial statements, and news trends to predict stock market movements and make informed investment decisions. Analyzing data from social networks to understand user behavior, preferences, and trends, which can be used for targeted advertising, sentiment analysis, and influence tracking. Used to extract useful information and insights from text data like emails, documents, and web content, it's widely used in customer service research and content analysis. These are just some of a variety of applications of data mining. There are many, many more. We shall now explore in a bit more detail the initial phases of CRISP-DM. We add this additional phase 0 to help understanding the process of how data should be collected. The data acquisition process is often very tedious. In this phase, you need to make sure that your data has quality. Quality of data is defined by its accuracy, completeness, consistency, and reliability. In this phase, you need to identify the potential problems that can be solved by the data you have. Essential things to be determined in this phase are business objectives, data mining goals, definition of project success criteria. Now that you know what your problem is, you can start to understand the data that you have at your disposal. This process is also known as data exploration. This phase and the next one will typically take around 90% of the time and effort in real-world scenarios. In this phase, tools for data manipulation and data visualization are often used, and understanding and applying statistical methods to reveal obvious patterns in the data is a must. In this phase, you're required to pre-process the data into a suitable format to be used by the machine learning models in the next phase. The process includes selecting important columns, sampling rows, train test split or cross-validation, creating or deriving new compound variables, filtering data or filtering out irrelevant data points, merging data sources like data aggregations, imputing or removing missing values. Let's now see how we can apply data mining to help a fictional winery business to crush its competition. Grape Extractions Winery has acquired data from a trusted source that contains the chemical composition of wines and their quality rating. Their business objective is to win the local Timbun Region Wine Festival. To do that, they need to do two things: know how to produce a top quality wine and also know which wine to put forward for the competition. The data available is a CSV file with a series of quantitative measurements of a particular wine and the rating of its quality by a wine evaluation expert. A simple way to start understanding the data at hand is by performing exploratory data analysis, or EDA, which may include various techniques. A popular technique is using a correlation plot to see which of the quantitative measurements is contributing the most in the positive or negative sense to the quality of wine. Another way of looking at our data is by visualizing a histogram of the target value or wine rating and thus see how its values are distributed. What we found in the previous phase, data understanding, by using the EDA techniques dictates to a large degree which data preparation methods are we going to use in this phase. Common data preparation will focus on generic data cleaning, such as dealing with missing values, normalization, and feature engineering. Also, discretization and other type transformation methods fall into this phase. For our wine data, it turns out that generating some new features, like for example acidity divided by sugars, and making the target variable binary, where 0 represents all lower quality wines with a rating less than 7, and 1 represents all higher quality wines with a rating greater or equal to 7, greatly improves correlation. In conclusion, good data preparation is key for extracting valuable knowledge from data. That means understanding well the initial phases of the CRISP-DM methodology is imperative for good data analysis. In the next module, we will focus on the actual machine learning algorithms and evaluation methods that are used to analyze the data. See you soon.